So this one, I've already got the graph here for you. You should be able to produce that graph by finding the zeros. What I mean by that is plugging in 0 for x, which would be 0 for x and 0 for x, and then solving for y, you would get plus or minus 3, and that. And then plugging in 0 for y, which would be this, and then getting x equals 9, which would be that. And knowing that it's a sideways parabola and sketching it in like that. So I'm going to try to do all of these in the same video, all parts A, B, C, D. We're doing dx, or we're doing perpendicular to the x-axis, goes like that. It means that I'm going to be doing dx. So on all my equations in terms of x, so that's why I have this work here shown for solving for y, because that's my value in terms of x. The one thing that I want to point out is that, well, actually, so I need to find the base, right? And that's this full length right here, because it's what I use for all my different little formulas and stuff like that. So there's kind of two ways to do it. I think a lot of you would wind up saying that the base is just, oh, well, I solved for that thing. It's root 9 minus x. Boom, done, right? And that's not quite right. You're almost there. There's two ways that I'm going to explain it. The first way is that, well, that's what the y is right there. It's the height of that thing off the axis, right? So this is y. So, which is equal to what I have right there. But notice that's not that full base, this thing that I'm looking for right here. So you should notice that this length here is also y. So my base is going to be 2y, which is, oops, undo. It's going to be 2y, which is 2, this thing, root 9 minus x. That's my guess where a lot of you went wrong already. But I want you to also listen to my other alternative way of figuring out that that's 2 minus 9x squared. So what this comes down to is you can always do top minus bottom, right? If I'm doing vertically like this, if I'm doing side to side, I can do right minus left. So this is not a function. You see that I wrote this plus or minus here, which you probably didn't, right? But I want you to see where this comes from. So this top side is the positive. So this guy right here is positive root 9. Hold on, that looks really weird. Undo, 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 undo. This spot right here is equal to a positive root 9 minus x, while this part down here is equal to the negative root 9 minus x. Now what I want you to see is that when I do top minus bottom, I do root 9 minus x minus a negative root 9 minus x, which is going to simplify to root 9 minus x plus root 9 minus x, and I have two of them, so it winds up giving me 2 root 9 minus x. So there's two ways to get there. Honestly, I think that this way is more efficient and easier, but I like how this connects to a lot of the ideas of how we've talked about finding those things. So that's my base, 2 root 9 minus x right here. First part is to do squares, and I know that for squares, I get integral of b squared dx, which is going to give me, equal to integral 2 root 9 minus x dx. I'm starting at this x value, and I'm going to that x value, so I'm going from 0 to 9. And it's squared. So you can square this out. The 2 squares out, gives me 2 times 2, which is 4, which is where that mysterious 4 comes from that you're like, where did that 4 come from? Integral 0 to 9, and then the square root cancels out with the square, and gives me 9 minus x dx. Next bit, part B, is equilateral triangles, and I know that that is root 3 over 4 times the integral of b squared dx. So, that, I'm not going to do too much work to get this. I did integral of b squared dx, which is this, right? Which gave me this thing. So, I'm not going to rework all of this. I'm not going to rewrite this line. I'm just going to go straight to this. So, I've got this times the root 3 over 4. So I get root 3 over 4 times 4 integral 0 to 9 minus x dx, which these guys cancel off and just give me that right there. So answer to A, answer to B. Probably wind up using this quite a bit as we go through these. Next part is semicircles. I know that is pi over 8 times b squared dx. So, once again, I have this right here is b squared dx. So, I'm going to get 4 times pi over 8, which is pi over 2 integral 0. So, I'm just replacing that with what I boxed in green up top. And the 4 right here canceled with the 8 to give me a pi over 2. 0 to 9, open parentheses, 9 minus x dx. Part D is isosceles triangles for which the base, right isosceles triangles, for which the base right here lines up on here. So that means that that becomes the base. You should know that there is my formula for isosceles triangles. It's just half of this guy right here, because it's really just a square that's been chopped in half. So I'm going to just, once again, reuse that that formula right there. So I just multiply that by a half, which gives me 2 integral 0 to 9 of 9 minus x dx. So those are my 4 answers.